The topic of our presentation is using the random forest classifier, which is a machine learning algorithm to predict the South African election results. We'll start with a high-level introduction, followed by the approach we used, then explain some of our key findings, and then lastly end with a brief conclusion. What is our problem statement? Again, the intention of our project was to predict the IEC South African May 2024 election results. In an age where political domains are continuously developing and evolving, there exists a potential need for predictive and accurate electoral modeling. This can assist in understanding voters' behavior and preferences, and to have some sense of predicting or anticipating the outcome of future elections, which may give political parties a competitive advantage, as it allows them to strategize more effectively and efficiently, as well as allocate the resources more adequately, reducing their cost and time. Given this problem statement, how can we then solution for this? Firstly, gather extensive data sets including voter demographics, historical voting patterns, socioeconomic indicators, and any available real-time data. Secondly, develop and train machine learning models using historical election data, utilizing machine learning algorithms such as decision trees, random forests, gradient boosting to identify patterns and trends that influence voter behavior. What is the benefit of these predictive models? As mentioned, a few use cases for this will be to enhance strategic planning and political parties, assist in policy making, market stability, public confidence and engagement, and any further academic and research contributions. So what was our approach? Using the available historical election results from 2009, 2014, and 2019, firstly, to get a better understanding of the data we performed in EDA. From the graphs below, we see that the number of registered voters over the past 3 years was 17.7 million, then increasing to 18.4 million, and then dropping to 17.4 million respectively. We also see that the number of parties over the 3 years ranged from 26 to 29 parties from 2009 to 2014, and then spiked in 2019 to 48 parties. Secondly, when selecting the models to use, we took into consideration that the electoral data is categorical and consists of multiple unbalanced classes. In other words, multiple party outcomes. Therefore, classification type algorithms such as these that we've highlighted are best suited to deal with this. Due to the simplicity and classification performance, the classification machine learning algorithms, random forest, decision tree, and the gradient boosting machine methods were considered. From the below table, we observe that despite its low predictive abilities, which may be attributed to the limitations of the data set from a feature and information perspective, the random forest classifier outperformed the decision tree and the gradient boosting machine in predicting the electoral outcomes. To discuss the model performance, some of the validation results, and the data limitations we experience, I will now hand over to my colleague Thabo.
Thank you, Lance. Yes, the data limitation were indeed a significant impediment to the model accuracy. In this slide, I will detail these data limitations. Several factors contributed to the low accuracy of our model, such as number of small parties. Many small parties made accurate prediction challenging. The second one is a lack of data. Insufficient demographic and socio-economic data limited the model's precision. The third one, voters' opinion. Understanding current voter sentiment is essential for accurate forecasting. The fourth one, consistent dominance of ANC. ANC has consistently dominated election and skewing the model prediction. Below are visualization generated from the random forest classifier. The confusion metrics show a high false negative rate, revealing the model weakness in identifying specific parties. This weakness is reflected in the overall accuracy of the model. The second graph is actual versus prediction. While most party predictions align with expected outcomes and follow a linear trend, some data points deviate from these patterns. This deviation may be due to an imbalanced data set, which impact the model accuracy. The third one is the number of voters for the last 3 elections. Although the ANC has dominated as the winning party, the number of voters has declined in the most recent elections. This decline could be attributed to various factors, including the rise of new parties that split from the ANC and other influencing elements. The MK party serves as evidence supporting this statement. Our analysis shows that the random forest classifier has outperformed both the decision tree and gradient boosting machine in terms of predictive accuracy. Despite this, the model accuracy from predicting the winning party stands at 29%, which is very low in this case. And we looked at other elements such as data constraints. Several data constraints has impacted the model performance, such as insufficient historical data, insufficient voter information, and external influences outside the dataset. This include IEC data access limitation and incomplete data due to POPIA regulation. Our conclusion from this project is that the predictive value of our model is currently limited by the quality and scope of available data. However, this research lays the groundwork for the future improvement and studies highlighting the area where the data enhancement is crucial for the better predictive accuracy. Thank you.